Hi, my name is Silva, and I'm part of the team CBEST, the Commercial Building Energy Savings Technology. We're a software as a service solution for HVAC optimization. CBEST went through the LabCore program, which was a 6-week intensive entrepreneurial training, teaching scientists and entrepreneurs alike to connect with customers in the field to learn how they want their technology built, what solutions they need, and what problems we could solve. So what is CBEST? CBEST is a software as a service solution, optimizing commercial building energy use. We do this by auto-tuning and controlling the HVAC system for up to 30% of energy savings for commercial buildings. This requires no upfront cost and can lead to savings in just as little as 1 week. Now, how does CBEST do this? Well, by utilizing 4 key components. Number 1, advanced performance control strategies. Number 2, by doing self-auditing and modeling. Third, it has predictive algorithms requiring 0 upfront capital. And finally, it does deep machine learning, allowing CBEST to learn from the past and enable it to be better in the future, always changing and always improving. Ultimately, these 4 key components provide a measurable and immediate impact on the energy use of any commercial building. But why now? Well, currently HVAC systems are 40% of the total energy costs in the U.S. commercial buildings, which is an overall about 10% in the whole United States. It's a huge opportunity to cut costs and to cut energy use. Additionally, because more and more technologies have come out on the market, consumer reception to these technologies is much more open, and there's much more traction by companies doing similar things, which is a good sign for a company like CBEST. So what is the problem? Well, currently, HVAC systems are quite frankly over-engineered. They're built to handle 2 days at the most optimal point. Throughout the year, at the different temperatures, they handle the coldest day and the hottest day. And on both those days, the HVAC system for a building is perfect and optimal and efficient. Every other day out of the year, when it's not handling those 2 extremes, it's actually inefficient. This can lead to a lot of energy savings that are not captured by the property manager or owner, and high increase in the energy use by the HVAC system. So ultimately, what begins to happen is you have these HVAC systems that increase the energy cost and increase the energy load. And as a building owner or manager, you may not understand what that is. So what you've got to go do is get an audit. And so you go get an audit, sort of a prescription for what's happening in the building, kind of a diagnosis, if you will. But these audits can be timely and they can be expensive. But let's say you get one done, you get the prescription, and now all of a sudden, to act on that prescription, you need to invest in usually capital, heavy, and intensive retrofits, which often have a long ROI, making it difficult for building owners and managers to make their buildings much more efficient. Ultimately, even if you do install these retrofits, they may automate efficiency, but they don't necessarily optimize nor predict. They get your buildings to sort of a stagnant point where it's a bit more efficient, but it doesn't actually change. And as we know, buildings are dynamic and they change all the time, and the technologies that support them should do the same. So therefore, we've developed CBEST. What CBEST does is it looks at every day of the year, and it finds an optimal point where it can adjust the energy going into the HVAC system to provide the right temperature within the building, but reduce the energy load by quite a lot. And what it does is every day CBEST is running is it's connecting to the HVAC system itself and understanding what's happening there. And it's also connecting to the cloud and understanding what's happening in multiple parameters around the building. For example, the CBEST system will learn about the occupancy of the building, the temperature inside, the temperature outside, demand response prices, and a multiple handful of other factors that it will take into account to understand what is actually happening in the building. Then every day, it records what happens and it learns about it. It does this every single day to be able to look into the future and understand how to make the HVAC system more efficient day after day. What this ultimately means is that that CBEST system, plugged into an HVAC system, makes it more efficient every single day and more valuable every single day. Ultimately, this increases the HVAC efficiency, saving up to 30% of the energy costs for a commercial building. The self-auditing provides a report of energy in real time. Because the CBEST system is learning through the HVAC system and through the cloud what's happening in the building at any moment throughout the day, at any day throughout the year, it can give building owners and property managers a real-time report on what is happening within their building. Additionally, because it's doing this deep learning, it has predictive and performance optimization with a 0 capital cost. And this ensures that your building is saving the second CBEST is plugged in, very quickly after as well. And finally, and one of the most important parts about CBEST that makes it different than other technologies, is the deep machine learning. Because this means that CBEST is never stagnant and it continually improves to make the building more and more optimized. Every day that goes by, it learns a little bit more and it becomes a little bit more optimized. So how does this all work? Well, think of CBEST as a black box of strategies. What CBEST does is it plugs into the BMS, so the building management system. The BMS looks at all the different systems throughout a building, one of which is the HVAC control system. So once the HVAC control system and CBEST are hooked up, CBEST starts to look at all the different parameters within the building, both those in the cloud and those within the building, such as the occupancy, the temperature inside the building, temperature outside the building. And what it does with this handful of parameters is it begins to analyze and look at all the data that's coming in to understand what is actually happening in the building. Taking this data, it actually builds a model to understand even deeper and further what the building is like, the energy needs, the energy requirements, and what it needs to do to make sure the HVAC system is at most optimal. Finally, what it does is it sends a recommendation to the HVAC system and also something that's viewable by the property manager, property owner. And this recommendation is basically saying, if you would like your HVAC system to perform optimally, here are the things you need to do. Or here are the things I can do, in fact, as a CBEST system. The property manager and owner say, this is great, go for it. Then CBEST goes, and it actually takes control of the HVAC system, reducing energy load and energy capacity on different pieces of the technology, while maintaining the same comfort and optimal levels within the building. So fortunately, we've been able to try this here at the Lawrence Livermore National Laboratories, at least from a simulation standpoint. What we've done is we've set up CBEST in one of the large data centers here to understand what would be the recommendations it would make after analyzing the data and modeling the building. And what we've seen is that the recommendations made by CBEST could lead to a savings of 14 to 20% throughout the year. This is huge, especially because these recommendations don't even include the demand response, which is something we would see on the outside of the national labs, out in the marketplace. So while this didn't actually save any energy, but just provided information on what it could do, it's promising and something we're really excited about and plan to test more and more buildings to get more and more data like this. So what does the market look like? Well, in California alone, office buildings spend about $152 billion yearly on the energy costs just to run HVAC systems. With over 660 million square feet of large commercial office space in California alone, you're looking at about $2,300 spent per kilowatt hour per square foot per year simply on HVAC costs. This is huge. Take it a step further, to look at an average California building, an office building, say 200,000 square feet, they would normally spend out $50,000 per month on the HVAC costs. With CBEST performing at its best and being able to save about 30% of that per month, it can help those building managers and owners actually capture $15,000 per month of costs that were going to an inefficient HVAC system. This is a big win for CBEST, and this is a big win for buildings throughout California. And of course, with a market this big, we're not alone. There's plenty of great competitors who have great technologies as well, some of them very similar to CBEST. For example, one of our closest competitors, Lobos, has a similar demand response function where they can look at demand response prices and be able to adjust themselves accordingly, something CBEST can do as well. Additionally, they also have performance optimization where they can actually take control of the HVAC system and tweak it and tune it to actually reduce the energy load of the technology. Similar to us, they have promised savings of up to and over 20%. But what they're really missing out on is two key pieces, the predictive optimization and the self-audit optimization. What this basically says is that they are not doing the deep learning that CBEST is doing to understand what could happen in the future and to understand what's happening minute by minute in real time. Another close competitor is Building IQ, who has very similar traits to CBEST, but is still missing out on the ability to understand what's happening in the building minute by minute. Why this is important is because with CBEST, you can plug it in, and within a week, you can begin saving. With a technology like Building IQ, it may take multiple months for the building to actually be understood by the technology being plugged into the HVAC system. Those savings of just a few months is enough to cover the cost of another retrofit that would happen otherwise. So what do we plan to do? Well, in the next 1 to 3 months, we are continuing to do the customer discovery. We've interviewed over 80 different customers in the last couple months and plan to do up to 150 more over the next 3 months. We know this is a big market, but one thing we've seen with customers is that there's not a lot of uptake of technologies. And so we want to understand why and what can we do to build our technology in a way that the customer acquisition is much easier. One of the ways we're going to do that is I will specifically be getting LEED credential certification, as well as a building performance analysis certificate, allowing me to understand more from the technical side what is happening in the building so I can be able to communicate better with the engineers. Additionally, here at the National Labs, we'll be piloting 1 to 3 more sites. We're currently working on that as well. These pilot sites will give us more validation that the technology can perform and perform well. Of course, this all comes with a cost, and so we'll be seeking additional startup funding to help elevate the technology and move it along quicker. Of course, we're also going to be looking on the outside of the labs and trying to begin building partnerships with folks in the marketplace who we can begin signing up to be potential first customers. In the next 3 to 5 months, we'll dive deep into software development, funds permitting, and really try to build out an MVP while continuing to talk to customers, understand their problems and the needs they have. Finally, in the next 5 to 12 months, we hope to launch an MVP product, a minimal viable product, something we can get to the hands of customers that they can use, they can test, and they can begin saving from their very inefficient HVAC systems. Currently, our team is built of Yingning Chen, a principal investigator who has 18 years of building energy efficiency and control system experience, myself, the entrepreneurial lead, and Dr. Roger Werney, the Deputy Director of the Industrial Partnering Office here at the Lawrence Livermore National Laboratories. So thank you very much for joining us today. If you have any questions, feel free to email me at ejsilva@ucdavis.edu. Thank you.